Yes, you're audible.
Okay, thank you so much. So, hello everyone. I hope you're doing well. So, we are in the second season of the day. We are still tackling our paradigms of OOP, and our second paradigm is inheritance. So, from the word inheritance, what do you guys know about inheritance? Like basic terms, what do you know about inheritance? Not even technical, not even the programming part of it. Anything you know about inheritance?
Being taken, like getting from somewhere else. It's from somewhere else. But like if I had, okay, let me just use the most basic example. If I have a house and I have children and I person already said to leave it for them, they'll inherit it. So inheritance is that process of passing on to the next.
Yeah. So that's a perfect example. So we have you know, in this case we can just say a parent and the children. So the children inherit the property of the parent. Vincent Karanja is going to be inherited. Yeah. So in this case, inheritance is like inheriting your favorite traits from family members. Only in the world of OP is the magical process that lets one object inherit properties and behaviors from other. So why do we inherit? Imagine you're a super dog with all the cool features of a regular dog, but with some superpowers thrown in. Inheritance allows you to reuse code, save time and energy by building on existing properties instead of starting from scratch. So, code reusability. Create a hierarchy. So, build a family tree of classes where child classes can share the awesome traits of parent classes. Okay, so you're building a hierarchy tree of classes where child classes can share the awesome traits of parent classes. So we say that class is a blueprint of an object, and we say that an object is an instance of a class. Uh, or am I confused? Anybody who's in the morning class, what's a class and what's an object? You got it? Anyone? So class involving is a blueprint or a template for an object. And an object is an instance of a class. So a class can have many instances, or rather many objects. So in this case, we have a parent class and a child class. So child class gets characteristics from the parent class. So uh, parent class can also be called a base class, stroke super class, stroke parent class. Right? So let's have a look at this example. So allow me to just carry this. Go right now, code editor, new file, inherit, inheritance, dot, dot. So we have a parent here, we have a child. We will see. We will see. So base class, or rather parent class. Hmm. Uh, class vehicle has two characteristics, brand and year, or rather has two properties, brand and year. Constructor. We talked about what a constructor is. We said we have two types of constructors. You have a default constructor and a parameterized constructor. So a default constructor is usually automatic. If it has no arguments in it, so that's a default constructor or empty. So in this case, we have a parameterized constructor, so which is this dot brand, comma, this dot year. Method to display vehicle information. So we said methods are functions that we can use to display the behaviors of a class or rather object. So void display info is a method that displays the information about vehicle. So we are done with the parent class. Yes, we are done with it, but we are not done like totally. All right. Derived class. So we said we need to we need now a child that inherits from the parent vehicle. So class car, this is now the child class. Class car extends. So the word extend here is now the one used to connect the parent and the child. Right? Are we together, Jim?
Yes. Yes.
So class car extends vehicle. What is vehicle in this case?
Please maximize your screen.
The parents.
I maximize or I zoom out. Are you able to see it?
Yes.
Okay. So what did we say vehicle is? Which class is vehicle in this case?
The super class of the parent. A class.
It's a parent. It's a parent class. Okay. All right. Super class. So the properties of class car are model. So the class car only has model. Okay. But it will carry the characteristics of the vehicle, which is brand and year. I don't know if you are together up to that point, guys. Our properties look fine. So here we have a constructor for car, which is child class car, which uses super to call the base class constructor. So the child in this case has its own constructor, which uses super to call the base class constructor. Okay. So car, we have string, brand. Where does brand come from? From vehicle, right? It was vehicle that had brand characteristics. Int year and this dot model. So this dot model is the child property, which is here. But where does this car get integer year and string brand? Where does it get it? It gets from superclass that contains brand and year, which is the parent. So here we have a kid who only has one code, whose constructor only has this dot model. But the kid is inheriting brand and not a year from its parents. So we use super to call the base class constructor. So this super has been used to call the constructor of vehicle. Are we there? Silence means we're there, right? So method to display the car specific information. So here we are going to display the car specific information, right? So void display car info. So here we're just going to create a method for car. Display car info. This is the function for car. Display car info inside the function. We are going to call the method of the parent. Display. Where is display info? It's in there. Choose the method of the parent. So this kid says, I have a method, but inside my method, please refer to my parent. Call the base class method. Okay? Call the parent class method. Then you print model. Then you refer to the attribute of the child class model, which is just here, like 18. So we're done giving the two models. Now, we now want to create an instance of the car class. Okay. We now want to create the instance of the class car. Writing an object must contain the class name. So car, object name, then we refer to the constructor that we gave to the child class, which is brand, year, and model. Then for it to run, for all these functions to run, or rather, for us to be successful in this, we have to call the method from both base and the right classes. So car.display car info. Remember, display car info was the method for car. And inside the method for car, we again called the method for parent vehicle. So the vehicle comes with all its properties, gives it to the car, which is its child, then the child now inherits all those properties. So let's see if this vehicle has given the child properties. Have you seen it? Have you seen it?
Yes.
Let's observe this. Let's observe the code. Just observe the code and ask questions. So, do you have any questions with regards to this? Have you got something from inheritance? Have we inherited something from the code? Guys, have we inherited something from the code?
Yeah, the model brand India.
Have you seen now something that is inheritance now coming to being realistic?
Yeah.
You can change this parent. Can you work with a parent and a child? Can you use a human being example?
Yes.
Okay, what do we name the parent?
Parent.
What name can you name the parent?
Boniface.
Bonnie, right? So Bonnie, what's your skin type? Skin and your height, right? So let's say your kid will inherit your skin and your height, right?
Okay.
So this dot skin, this dot is that height. So we now have a class, a father called Bonnie, who has a skin type and he has some height, and we want his kid to inherit his height and skin. So void display info, we give Bonnie some a method that will display information. So this to skin, no, we're done with that constructor. So void display info, print brand, which you can say that is skin tone, skin, height, height.
Hapo kwa skin umeandika skint.
Sorry. Okay, so his child is now we've given this guy everything. Now his kid will now inherit. Okay. So class car. So what name would you give your child?
Elkana.
Zakayo.
Elkana. So Elkana will extend Boni. Have you seen it? Class Elkana will extend Boni. Okay? Because like your child is the extension in layman's language, right? Your child is the extension. So constructor for child class, which uses the super to call the class constructor. So this child has his own constructor, but uses super to call the constructor of his dad. So we say here Elkana, the car is called Elkana. Elkana, string, skin. Elkana has we forgot to give Elkana something. So Elkana has its own characteristics apart from just inheriting from his dad. So which characteristic can we give this guy? String. Personality. We don't have to inherit a personality. So Elkana will inherit brand, which was the skin. It is the height. And his personality. So this dot personality stands for Elkana. But Elkana will have to, yes?
Is this that or C++?
It's the same thing. They are closely related. Super,
Okay.
brand, comma here. So what is Elkana inheriting from his dad?
Skin and height.
So yeah, we still have some errors, but we'll just go as we proceed. So method to display the kid's information. So this kid also has his own method. So void display car info. I'll just name this Elkana info. Elkana info. Then inside the Elkana information, Elkana will also display the info we start. So we found
The
the yes.
spelling of Elkana on the display info.
Oh, Elkana will call his dad's method, which is display info. Here is the dad's display, right? Okay. So print model. So we said we replace model with personality.
Personality.
So
Again, on the void display Elkana, you have written Elkana.
no, it's not personality. You know, it's just okay. So now we are done inheriting, right? Comes over to here. This should not be here. Okay, that's it. So we are going to create an instance of Elkana. Okay, we're still talking about Elkana. Here is the kid. So Elkana is this class name, Kana. Then we name this whatever default object, that's small b. Then we say Elkana. Intro. What is Elkana skin? Hey, which skin are you to give this guy? Yeah?
Black.
Chocolate.
Hey, 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 hey.
Chocolate.
Okay, to give up say chocolate. I think we don't want dark. Okay, what else? Height. What's your height? 150.
Bradley
What?
tall.
6'2".
Yeah?
6'2".
Okay. What is 6 in centimeters? That should be 190. 195. What's the personality of Elkana? It says calm. So accessing the method from both base and derived. So we are only going to access the method of Elkana because inside Elkana's method we have this stats method. This one. So we are going to use Elkana's object. Display Elkana. Yeah. Let's now go step by step. Constructor for vehicle. No, not vehicle. Can somebody spot the error?
Is there a comma separating this dot skin and this dot height?
Yeah. Well, that was close. I couldn't even see that. Thank you so much. So let's now run this guy. So Elkan has inherited chocolate, height, and his skull. So he had one characteristic what took 2 points that. Cousins, have you seen that cousins?
Yes.
Yes.
Okay. I'm still open for many questions. So that's how you can get it. That's how inheritance works. Parent, child.
Can you use private methods like encapsulation with
Inside this,
inheritance? Yes, inside inheritance.
I've never tried it, but unless now we are using multiple paradigms in one thing. But if it's just inheritance, it's just one thing. Plus, you know,
Kind
it has to be public for inheritance to occur. It has to be public because now you will not be setting or getting anything like just a child that's trying to borrow something from the dad. The only thing here that's key is the word extend. The word extend now says, me as a child, I'm extending my dad.
kindly share the example.
Yeah. And then can you like have multiple inheritance? Like can a parent have like 2 children?
Yeah, a parent can have two children. I've tested the code. You can have multi-level inheritance. You can still have another class. Let's say class A is class Elkanah. You can now have another class called the James. See, we have levels of inheritance. We have one called multi-single level. And yes, we have the diagram types of inheritance. Okay. So we have one message. We have a single inheritance, multi-level, multiple inheritance, multiple. Then we get one that says class that has the classes. Yeah, I think this one can work. So in this case, in the first form, okay, it's a LinkedIn thing. Let me just do it for it again. So single level inheritance, we have one parent and one child. Base class and derived class. Okay? So in this case, we have a multiple inheritance. Multiple inheritance, where we have 1, 2, 3 base classes, and we have one derived class. So we have 3 parents and 1 child. Just like maybe you can use 2 parents and one child. Hybrid inheritance. This one, I'll get a better example for this that shows how which is which. Multi-level. We have a base class. This is the parent. This is the child. And this is the grandchild. Okay. Hierarchical. We have base class. One parent, then etc. So hybrid, let me get a better example for hybrid. Hybrid inheritance. I guess they might be access to this. Okay, let me just search. Can I share this with you?
Yes.
Yes.
Let me just share this. What is that? I don't know how this guy hidden his code. Seems you can't see until you log in. No, They didn't just say this stuff, but get some. Yeah, I think one more scholar has. Yeah, different types of inheritance. We're just going to look at hybrid. What's in the one hybrid or hybrid? Hybrid inheritance combines different inheritance types like single, multiple, and hierarchical within one structure, which allows you to use various features and functionalities from multiple parameters. So here you're combining many inheritances. This approach, classes can inherit from multiple sources, which helps in sharing common traits among related classes. So classes. So take this as a polygamous family. You have one that, but you have, all of you have many mothers. See? Something like that. Yeah. Then you post this. You're able to see it. Allow me also to add it in the further reading. There you go. Are we now okay with the inheritance? Can we go to the next
Yes.
one? Can we go to the next one, guys?
Yes.
Just
Yes.
by show of hands. By show of hands, can we go to the next guy? Karen Ryan. Okay. In case you have to understand inheritance further, this will help you further. Okay? It's the same thing. Right. Polymorphism. What does the word poly mean? The word poly means many. Welcome to the world of polymorphism, where one method can wear many hats. One method can wear many hats. Think of it as a party where all your favorite classes gather and each one brings their own unique twists to the same method. So one method, many forms. Just like a chameleon, change of color, polymorphism allows different classes to redefine a method while keeping the same name. So just take it as a chameleon that has the same name but different colors. I don't like chameleons. It's actually my biggest, my biggest fear. I don't know how I ended up using that example. This ability gives you the power to call the same method on different objects and get results that match their unique behaviors. So just say one chameleon, many colors. This diagram, you can see an animal, class animal, which has a method sound. Okay? An animal can be, what are some of the different types and examples of animals? Examples of animals.
Wolf.
Wolf.
Rabbit.
Rabbit. So
Elephant.
yeah, so we have animals. So different animals have different sounds, but they all fall under animal kingdom, animal in biology. So you can see in this case, we have an animal that makes a sound, but this animal can either be a cat or a dog, right? But they are all animals. So let's have a look at this. Just a minute. So let's first start this way. Like animal class is the base class with a method make sound. So we have a parent class. Here we also have a parent class, animal. The dog and cat classes are derived classes that override the make sound method with their own implementations. So the keyword in inheritance was extend. Here we have override. Okay. So the derived classes override the method of the parent class. In the main function, instances of dog, animal, dog, and cat are created. The next one method is called on each object, demonstrating polymorphism as the appropriate version of method. So let's take this code to our VS Code. Now run. Is my screen too small? Are we seeing my code?
Yes, we can see.
Yes.
Okay. So we have our base class or our parent class, right? Animal. Method to, so we give this parent a method that will be overridden by derived classes. Okay? So void make sound. So the method in this case is make sound. Then since we know that our method is a function, inside our function we say animal makes a sound. Right? We all know that animals make sounds. Okay. We now have our first derived class. Derived class dog that overrides make sound method. Class dog extend animal. Okay. Class dog, I mentioned that keyword is overriding, but also we are also extending the parent class. Class dog extends animal. Do we know why we are extending? So you're trying to get that. We're trying to override the method make sound. At override, or rather this is how you write the override. Void make sound, then inside that we print dog barks. We're using the same method of animal. Notice that. We go to cat. Derive class cat that overrides make sound method. Class cat extends animal, then inside it we override it as well. So after that we give our print cat meows. So notice that we're using the same method of animal. Make sound, make sound, make sound. So we are done giving it to derived classes. You can have another animal of your choice. Okay. So we are now going to create instances of animal, dog, and cat, which are simply the objects of the three classes. Class 1 is animal. We give it an object called animal is equals to animals constructor. So since we are now aware that we can have an empty, we have default constructor contains nothing inside. So we just give it animal, the constructor with nothing inside, or the parentheses have nothing inside, then you have semicolon. Same to dog, same to your cat. So for your animals to make some sound, we are going to call make sound method for each instance. For us to say that a cat meows, a dog barks, we must call the method that had that print inside. So animal.make sound, dog.make sound, cat.make sound, and we're going to see what that has. So one method, different forms. One method, different forms. So you can see the method at first said animal makes a sound. The same method said dog barks. The same method said cat meows. So as we can see, we have one method having many forms. Let me know if it's not bad. Just observe it, then I'll ask you questions. So can I now ask you questions? Which is the method that is being, which method is appearing in many forms?
Pardon?
Which method is here? Okay, which method which is the method here that has many forms?
Make sound.
Make sound. Make sound.
Brilliant. Somebody else?
Sound.
Somebody else?
Make sound.
Yeah. So the method here that has many forms is make sound. So give me the first instance of it. What was the first form of it? What was the second form of it?
Back.
Back. The first one is?
Make sound.
Mhm,
Then backs. I think.
mhm.
Yeah.
Yeah. So you can see this method here says animal makes a sound. Second part of it says, dog barks. That one says cat meows. And that's how polymorphism is into place. Let me get you a diagram. I'm trying to get the simplest one. I'm getting things that are complicated. Yeah. Can someone see how this is? We have a shape here. That's the first class, or can say superclass, which has area, double. Other form, the shape can be a rectangle, and the shape can be a circle. So you can see one shape can appear. Like we have, there's a shape that can appear in many forms. We can be a circle, we can make it a rectangle. Let's see some. I can't see that one. Unless you guys, if you get one, share with us. Yeah, that's how polymorphism is. I believe it's not hard, right?
Right.
Sharon Kipsang.
Direct.
Sharon Kipsang, say hi. Sharon Kipsang, please say hi.
Hi.
How are you, Sharon?
I'm fine.
We've seen. Do not hide. We've seen your cousin. Yeah.
Okay.
Thank you. Somebody else who has something to say about polymorphism before we go to abstraction? Nothing? Good students. Let's proceed. Somebody had something to say. I don't know what that is. So let's now go to abstraction. Guys, abstraction is a bit long one. Just pay attention. So abstraction is like magic lens that let users interact only with the essential features of an object while keeping the intricate details hidden away. So this is data hiding. Okay. So it's all about just hiding something from the users so that the users can only use the essential features without seeing everything. So what is abstraction? Imagine you are using a remote control. You don't know how the remote control works internally. You just press buttons to change channels or adjust volume, just as how we usually do. That's the essence of abstraction. It allows users to access just a subset of an object characteristics and operations, simplifying their experience. Nobody knows what is inside a remote. Nobody knows how it works. But because we have the buttons, we can just make the work done. So abstraction takes complex systems and present them in a straightforward manner. For example, the remote. See? Like you just access a button. You don't have to know how it works. Oh, there's an internet, there's a motherboard. Nobody cares about these things. Think of it as showing only the tip of the iceberg, while the vast majority lies beneath the surface. So there's more to a remote than just the buttons. If you have a remote there on your side, I'm sure you know what a remote is. Remote control. Yeah, this is it. Does anyone know what's inside this remote? Anybody? Do you know what's inside this remote? Okay.
Yes,
Do you know
like
what
a motherboard. Motherboard.
Yeah, there's a motherboard. But do you know the functionality of the motherboard, like what it contains? Or
I guess
do you
the
know if I
sensors,
press this
maybe.
place in the motherboard, this will happen? Do you know that?
Maybe a sensor.
Maybe a printer. Okay, do you know what V plus means?
Adding volume.
So we can see we're just simplifying our lives by just accessing what we need. We don't need to know what a remote motherboard is, where the volume is located inside. We don't need. It will make our life very hard. Sharon keeps saying, do not turn off your camera. Do not. Stay with us. I know you turned it on accidentally, now you don't know how to turn it off, so you have to survive.
No.
You don't know how to turn it off, right? Okay. Brilliant, but don't turn it off, please. Yeah, so let's see what abstraction is. Oh my, it's long. Okay, let's just fade it. Abstracting. It's long. Okay, let me get you a very short example. It's very long. Get a very short example. Just give me like 1 minute. 1 minute. I've consulted my AI. It has given us a very short example. Okay, so let's have a look at it. So here, let me take the code for that. See. So the vehicle class is an abstract class. We'll have an abstract class with an abstract method of accelerate and a concrete method of display that. The car class is concrete that extends the vehicle and provides an implementation for the abstract method. In the main function, an instance of car is created and used through the common interface provided by the vehicle abstract class. So it might sound Greek because I'm not saying it. So we have an abstract class here called abstract class vehicle. So we are writing abstract class vehicle. We are writing an abstract class. We are denoting our abstract. So string brand, the property of the vehicle. This is the parameter constructor that shows the properties of the vehicle. This is the brand. Abstract method. Abstract method we avoid accelerate. So here we have an abstract method, which is see, we've given this class, we've given this how do you say? We've given this the behavior of this vehicle. We all know that a vehicle accelerates. So a method is also used to show behavior. So behavior of accelerating. Then we have a concrete method that says void is a concrete method that now displays the information of the vehicle brand. Void display brand, inside it print brand. Then we now have a concrete class that extends the parent class, or rather the abstract class. So class car extends to vehicle. So the constructor of class car has string brand, which is actually fetched from vehicle. So super brand. So you can remember from inheritance. When we override, we are now going to override the accelerate method, the abstract method, accelerate. Void accelerate, then inside it, we say print brand car is accelerate. Then we are going to create objects. Create objects for them, for the class. So car, this is the class that was, this is the concrete class. Class my car is equals to car into Toyota. So now constructor is the vehicle brand Toyota. So my car dot display brand, my car dot accelerate. So let me run this and provide another further elaboration because it seems the PPT guide give us something better. Brand Toyota, the price of it. So allow me to give this to you and ask PPT, make it very short for you also. Oh, sorry, here's the code for polymer. Sorry, I missed. So kindly ask GPT to explain that to you in layman's language. As I also try to get the shortest description of it.
So abstract basically has both polymorphism and inheritance.
Yeah.
Okay.
Just trying to get the best explanation to it. Explain is to avail. Shorten them. So think of the vehicle part as a general blueprint for anything that moves, like a car or a boat. This blueprint says all vehicles must have a brand and must know how to accelerate, but it doesn't say how they accelerate. It also includes a ready-to-use method for displaying the brand. The car part is specific blue. Is a specific vehicle built from the vehicle blueprint. It has to figure out its own way to accelerate, like printing cars accelerate. In the main part, we simply create a car named in a car and tell it to display brand, accelerate, using the rules set by vehicle, blueprint, and car specific instruction. Think this work. Somebody text here so that I can reply. Okay, number 9. So just digest that, then ask the questions. Just digest it. So I think, yeah, time for questions. Kanana Masi. You can ask questions. You can still digest that because I know you might need some practice on it in mixing in the three paradigms you've covered. You might need to digest it. So I'm actually willing to let you digest it for the remaining 30 minutes of the lesson as we prepare also for the evening class.